So guys, videos, turn on your video. Okay, now, so today we'll talk about Newton's law, how to apply Newton's law on system of particles. And also we'll take those two questions. So there are certain ways to solve those two questions. Okay, I'll tell you a few ways. See, Newton's law on system of particles. Suppose in your system you have many particles like n particles. Particle number 1, particle 2, particle 3, particle 4, and particle n. This is your system. There may be other particles outside this system, no problem in that. Just assume that this particle 1 is experiencing some force F1. Particle 2 is experiencing some force F2. Particle 3 is experiencing some force F3, and like that Fn. This force will include both internal force as well as external force. Means particle 2, particle 3, 4, particle n may also apply some force on this particle 1, and some particles that is outside this system that will also apply some force. So this force includes all the forces, internal as well as external. So if you write force is mass into acceleration, mass of first object into acceleration of first object. Similarly, force on object 2 will be mass of second object into acceleration of second object, and like that, force on nth object equal to mass of nth object into acceleration of nth object. Just add it. You will get F1 plus F2 plus F3 like Fn equal to M1A1 plus M2A2, and like that Mn An. This is the net force. Net force. We can see that the net force acting on the system. Vector sum of all the forces acting on different particles. If you do vector sum, it will give you net force on the system. That is M1A1 plus M2A2 plus like that Mn An. This force Fnet net force, it will include two forces: internal force plus external force. See, internal force will be 0 because see, whatever force F1 will apply on F2, whatever force object 1 will apply on object 2, same force means same it will be same in magnitude, but in opposite in direction. Same force object 2 will also apply on object 1. Whatever force object 1 will apply on object 4, same force will be applied by object 4 on object 1. So it will be same in magnitude, but in opposite in direction. Say they will they will nullify each other. So internal force will become 0, and we can write external force equal to M1 A1, or you can simply write in short Mi Ai summation I equal to 1 to n. Understood? This is the concept of how we apply Newton's law on system of particles. I'll take question, then you understand in more. जोशुआ तुम भी कर लो अपना वीडियो ऑन.
ओके सर.
अर्ची तुम्हारा वीडियो ऑन नहीं है.
सर नेट थोड़ा वीक चल रहा है तो.
क्या हो गया दिल्ली में?
सर पता नहीं, वो मतलब बोलूंगा कॉल करके बाद. नहीं, बारिश नहीं हो रही आज.
ओके. तो जोशुआ तुम्हारे पेस में ये सब हो गया होगा. लॉज ऑफ मोशन पढ़ा दिया?
हाँ, अभी जस्ट पढ़ा के जस्ट हुआ है.
तो तुम्हें तो पता होगा ये सब चीजें, राइट?
यस, बट थोड़ा डाउट है कॉन्सेप्ट में अभी भी.
ठीक है, तो कॉन्सेप्ट क्लियर हो जाएगा तुम्हारा, तुम देखते रहो, करते रहो. Noted?
Yes, sir.
Shaina is noting. Ayushi, none?
Sir,
Okay.
Yes, sir.
जोशुआ हो गया तुम्हारा?
Yes, sir.
तुम्हारा नाम क्या है? जोशुआ?
Joshua.
जोशुआ सही बोल रहा हूँ ना?
Okay, I'm okay with it. चलेगा, ऐसा कुछ नहीं.
ठीक है, ओके. कदम बोल दूं, चलेगा? पापा का नाम तो नहीं
हाँ
है?
सर, चलेगा. नहीं सर, नहीं.
Surname, man, that is fine. Okay. See, I'll take one question. This is ceiling. This is the row. And suppose there are few monkeys trying to climb, or this one holding it. Monkey number 1, monkey number 2, monkey number 3. Right? This monkey is trying to, not trying, going up with some acceleration 1 meter per second square. And this monkey is coming down with 2 meter per second square acceleration. And this monkey is going up with 1 meter per second square. And mass of the monkeys are like 2 kg, 3 kg, 5 kg. There is a point A here, over here. We have to find tension in the rope at point A. See, this rope is ideal, means massless and massless, right? And inextensible. We all know that in inextensible and massless string, tension will remain same everywhere, right? We know that. But in this case, tension will not be same everywhere. Why so? Like, see, this monkey is trying to pull. If monkey is going up, so monkey will try to pull the rope down. So because of the weight of the monkey, or like between the hand and the rope, there will be a friction that will be acting. So because of that, tension will be different. Yes, Avru.
53 न्यूटन है क्या?
कितना?
53.
नहीं बेटा, गलत. So अभी क्या होगा कि see, this is the string, and suppose if I am trying to climb this to up. So यहाँ पे क्या होगा ना कि because मेरे hand में, between my hand and this string, there will be a friction force. Because of that, tension will be different. Understood? So here, everywhere, tension will be different. Now, first I'll try to solve it using simple concept that we have understood till now. So method 1. So what we'll do, we'll draw the FBD of all the monkeys. So see, first monkey, second monkey, and third monkey. So see, if you draw the FBD of first monkey, its weight will act downward like this, 2g, that is 20 Newton. And here, tension will be different. Here, the tension will be, suppose, T1. Now you can see that. So between this point and this point, tension will be same. If tension is T1 here also it will be same because the string is massless. So now if you draw the ability of second monkey, so one tension will be downside, that is T1, because if this is T1, this is also T1. Mg will be downward 30 Newton, and here at this point tension will be different. So T2. And for monkey 3, if this is tension T2, this is also tension T2. So T2 will act downward plus its weight, that is 50, and T3 will be different. T3 will be different. And now you have to apply the Newton's second law. See, this monkey is going up. So net force should be in upward direction. T1 minus 20 equal to mass into acceleration. So T1 we have for 22 Newton. Here, this monkey is coming down with 2 meter per second square acceleration. So net force should be downward direction. So T1 plus 30 minus T2 must be equal to how much? Its mass into acceleration. T1 we have 22. Put it. Minus T2 equal to 6. So T2 will be 52 minus 6. That is 46. Here, this monkey is going up. So net force will be in upward direction. T3 minus T2 plus 50 equal to mass into acceleration. T2 we have 46. Put here. So T3 will be 46 plus 50, 96 plus 5, 101 Newton. But this is little long. First you note it down. So this we have done like using the FBD of each and every object. Now we'll apply the concept of system of particles. How? I'll show you. सबको समझ में आया ना? Everyone understood ना?
So how did we get T1 plus 30 minus T2 is equal to 3 into 2?
See, draw the FBD of second monkey. So for this second monkey, this is T1 and this is T2. The weight is downward because monkey is coming down with acceleration 2 meters per second square. So net force should be in downward direction because monkey is coming down. So net force is T1 plus 30 minus T2. Understood?
Yes, sir. Yes.
अर्चित समझ में आ गया ना?
So
अब
the,
वो
Yes,
कैसे
sir.
करते? हाँ, China, tell me.
so the sum should give the total tension at A, right?
Not some. T3. See, this point is here, na? And here tension is T3. There is no monkey here. So from here to till ceiling, tension will remain same in this string, in this part.
Okay, so it's same as T3.
Yes. So answer is 1018. जोशुआ समझ में आया? सॉरी,
हाँ सर,
समझ में आया?
समझ में आ रहा है। यस सर,
Okay,
आ रहा है।
ठीक है, ओके। डाउट हो तो पूछ लेना।
ओके सर।
सर पिछली फिजिक्स की क्लास में बस वही 2 क्वेश्चन हुए थे ना?
हाँ, पिछले क्लास में तो खास वो हुआ नहीं था, कुछ उतना ही हुआ। अब तुम्हारा आंसर करेक्ट हुआ अभी तक या नहीं हुआ? अभी करेक्ट हो गया? डन ना? एवरीवन नोटेड ना? क्लियर? एवरीवन? Okay. Now I'll tell you second approach number 2. Approach number 2, I'll tell you. See, method number 2. I will not draw FBT of all 3 monkeys. What I'll do? I'll just draw the FBT of this complete system. This is our system of particles. Because in this system, this T1 and this T1 are cancelling each other. They are internal. This T2 and this T2 cancelling each other. They are internal force, right? So net internal force will be 0. So now I'll draw FBT of this system. You can see that this system has how much mass? 5 plus 3 plus 2. That is 10 kg. And if you draw this the FBT of this system, so 100 Newton force will act downward, mg, and here one tension will act upward. So this tension we have to find. Okay, now net force should be, net force you have to find. So in any direction you can find, like no, suppose I do like 100 minus E. I just assume that T is less than 100 Newton. So 100 minus T, that is equal to, or you can say, oh wait, we know that net force, that is F1 plus F2 plus F3, only 3 forces, or no, wait. Net force is mass of 1 into acceleration of 1 plus mass of 2 plus acceleration of 2, mass of 3 into acceleration of 3. Suppose if you take plus y upward as positive and downward as negative. When T minus 100, T is going up, so plus 100 directing to down, so it is negative. M1 suppose 2 kg into its acceleration is upward, so plus 1. M2 that is 3, its acceleration is downward, so minus 2, plus M3 that is 5 into its acceleration is 1, so plus 1. So T minus 100 equal to 2 minus 6 plus 5, that is minus 1, sorry, plus 1. So T is 100 plus 1, 100 Newton, in 101 Newton, in one line, right? You can get the answer. That is how you can apply the Newton's law on system of particles. सबको समझ में आया?
Yes, sir.
Yes, sir.
Done? Okay. Now I'll take that question. This is smooth surface. There is a wedge. And this is suppose your box, any block. Suppose you can take, suppose I'm just taking the mass of both same, like both are same for calculation purpose. This angle is theta. Basically, I want to find the acceleration of these two blocks. But before that, what I'll do, I want, like step by step, we will go. Draw a BD of wedge and block. Okay, first we'll draw. Okay, we'll do that. Don't worry. First we'll draw a BD of wedge and apply Newton's law of motion in horizontal and vertical direction. See, one thing we know that if you draw a BD, you'll come to know one thing. See, for wedge, if I draw, we'll see that. First, you understand. I'll give you time to write. This earth will apply some normal force, some weight, and this block will also apply one normal force. That is N1, suppose. This angle is theta. Now you can see that if you break this into component, if this angle is theta, so of course this angle is theta. This angle is theta, so of course 90 minus theta and then theta. So this normal will have two components, N1 sin theta and N1 cos theta. Now you can see that this block can move only horizontally. So this force N1 cos theta directing towards down. So N1 cos theta plus mg will be balanced by N. And there will be this component. So that will give the motion towards right, right? We can see that. Because of this wedge will have motion towards right. So suppose this wedge has acceleration A towards right. Now, if I talk about this block, then we can see that this block will have one force mg and one force normal n1.
सर इसमें
हाँ.
सूडो फोर्स लगेगा ना?
I am not talking about pseudo force क्योंकि अभी हमने पढ़ाया ही नहीं.
ओके.
Pseudo force के अलावे मैं बात कर रहा हूँ. Pseudo force तो बाद में आएंगे, है ना? तो अब now see, as per the wedge constraint, we know that this block will have motion only along the common surface. As per the wedge constraint, what is the wedge constraint? Like now, this block neither lose contact with this wedge nor deform this wedge, right? So, as per the wedge constraint, this block can slide only along this common surface. May go up, may go down. Because of gravity, it will go down only, right? So now what we'll assume? We'll assume that, let's say, B is the acceleration of this block with respect to wedge. B is the acceleration of this block with respect to wedge, not with respect to ground. Because if someone is sitting on the ground, then that person will see that wedge is going right. So the block will also go to right. Wedge is going right. So block will also go to right with the same acceleration. And block is also sliding down the wedge with some acceleration B. So person sitting on the ground will see this is the net force of this, a net acceleration of this. Understood? Okay. Now I want to apply the Newton's law of motion on wedge first. We know that wedge can move horizontally only. So which force is responsible for horizontal motion? N1 sine theta. So N1 sine theta, that is equal to mass into acceleration. And there is force in vertical direction will be nullified, balance each other. So N is acting upward, N1 cos theta and mg acting downward. So N1 cos theta plus mg. So this is the Newton's law on wedge. Note it down till here. We'll go slow today. I'll make you understand each and every concept of this. सारा जितना भी कॉन्सेप्ट होता है ना, हाउ टू अप्लाई न्यूटन्स लॉ in vertical direction, in horizontal direction, along the inclined plane, along the line perpendicular to inclined plane. I'll tell you everything. And in the end, I'll tell you short trick. ये जो what I'm trying to tell you, ना, that is a very good way. But in the end, I'll also tell you one very complicated way by using the displacement, but that will be too complicated. So don't forget this. This B is the acceleration of, suppose this is A and this is B. Acceleration of B with respect to A, wedge, not with respect to ground. है ना? कल की क्लास का वीडियो देखा था? Did you watch that video? Studies class, math. I sent you.
Not yet, sir. I only came back from school today, so I'll see after this class.
Okay, okay. Noted till here? Now, next point would be, see, we'll just name this equation. First equation, second equation. Now, so which part is done? Okay, fine. Now for block B, suppose, apply Newton's law of motion in on block B in horizontal direction. See, we are asked to apply the Newton's law of motion in horizontal direction. So we have to break all the forces into horizontal and vertical component, right? Now you can see that. This angle is also theta. So this is vertical component and this is horizontal component. If this is theta, so 90 minus theta. So this angle is theta. Now you can see that mg has no component along horizontal because this is vertical. And we'll have one component along vertical direction and other component along horizontal direction, but that is towards left. Now see, because wedge is moving with some acceleration a, so along with wedge, as per wedge constraint, this block B will not lose contact with wedge. So with wedge, B will also go towards the left, right with same acceleration because this wedge is moving with a acceleration. So this block will slide down on the wedge as well as go towards right with wedge. So this block will also have a acceleration towards right and B with respect to wedge along the inclined plane. Now you have to apply the Newton's law of motion in a horizontal direction. So see, in a horizontal direction, now there is only one force that will provide motion in horizontal direction, that is n sine theta, and that should be equal to mass into acceleration. So what is the acceleration in horizontal direction for this block? What is the net acceleration of this block in horizontal direction?
A, sir.
No, A
B.
as well as B cos theta. See, this is B, na? This is B. So B will have two components, B cos theta as well as B sin theta. So the net acceleration, see, net force is toward left. So net acceleration should be B cos theta minus A. B cos theta minus A. Understand it? And along the vertical direction, if I apply, along vertical direction, if I apply, so what is the net force? See, net acceleration is B sin theta. So net force should be downward. Mg minus n cos theta equal to mass into acceleration. Understood? See, block B is going towards right with wedge, with A, and also sliding down with B. So if you are asked to write the Newton's law along horizontal, so there is only one force, n sine theta, that is towards left. So block will have tendency to move towards left. So that force equal to mass into net acceleration in left direction. So you have to break the this acceleration. So this would be B cos theta and B sin theta, and net should be B cos theta minus A. Understood? So this is equation number 3. This is equation number 4. Let me know if you have any doubt.
फोर्थ
Note it
इक्वेशन
down.
का वो आरएचएस कैसे आया?
R किसका? इसका
हाँ,
या ऊपर वाले इसका?
नहीं नहीं, नीचे वाले का।
इसका देखो, यहाँ पे तुम देखो सी, ये एक्सेलरेशन b है जो कि along the inclined plane है, and this is the acceleration a. तुमने इसको जब ब्रेक किया तो you got this n cos theta and this n sin theta, and here this is mg. You know that net force equal to mass into acceleration. So this is the net force, and see, block is also sliding down the inclined plane, na? So this is b. So this angle is theta. So this angle is theta. So you have to break this acceleration into two components: b cos theta and b sin theta. So net force equal to mass into net acceleration. So there is one acceleration in left side. There is one acceleration in right side. So net should be in the direction of force. So b cos theta minus a. Now there is one more component of acceleration. It means that अगर तुम्हें vertical direction acceleration है, तो there is a net force in vertical direction. So net force should be mg, क्योंकि acceleration downward है, तो net force भी downward ही होगा. So mg minus n cos theta equal to mass into acceleration.
ओके सर।
Note it down till here. ब्रो तुम्हें तो पता होगा, फिर जी में सब करवाया होगा, इतना डिटेल में करवाया था मतलब?
हाँ, पहले पहले फिर ये बहुत लंबा प्रोसेस है। डायरेक्टली अगर सूडो फोर्स लगा के कर दिया तो 1 मिनट का
देखो
सब।
सूडो, देखो सूडो फोर्स लगाओगे तो आसानी से हो जाता है, बट हम विदाउट अप्लाइंग सूडो फोर्स यहाँ भी मैं तुमको आसानी से 2 लाइन में करवा दूंगा. वेट, डोंट वरी, वेट. ये मैं
हाँ
तुम्हें
सर,
आई एम जस्ट टेलिंग यू द कॉन्सेप्ट कि you can apply Newton's law of motion in any direction. In the end, I'll solve this complete question in 3 or 4 steps. Don't worry.
हाँ, हो
But
जाएगा। वो एफबीटी दोनों का ठीक से बना है तो इक्वेट
हाँ,
कर दे।
हाँ, वही वही एफबीटी जो ठीक से बनाने के लिए ही तो मैं इतना समझा रहा हूँ. Noted, everyone? अच्छा, कदम मुझे दिख रहा है, नोट कर रहा है. ठीक है, करो. ओके.
Done, sir.
Okay. Now, I want to apply, कचरा हो गया. I want to apply Newton's law of motion on block B along the inclined plane and along the plane perpendicular to inclined. See, apply Newton's law of motion on block B along inclined plane and perpendicular to inclined plane. I want to give you guys 2-3 minutes. You try, then I'll tell you. Here is the video block.
अभी क्या एफबीटी अलोंग द इंक्लाइन बनाना है?
Yes, you have to apply Newton's law of motion along the inclined plane and along the line perpendicular to inclined plane. Just कोशिश करो, कोशिश करो. Done. See, here you have to apply Newton's law of motion along the inclined plane. So you have to, and plane perpendicular to inclined plane. So you have to break all the forces along the inclined plane and perpendicular to this. So there is no need to break this normal because this is perpendicular to inclined plane. So you have to break this mg. So there will be mg sin theta, and this will be mg cos theta. Now see, this block will have two acceleration. One because of wedge, that is A, and one because that will with respect to wedge, that is B. Now, along in the inclined plane, see, along the inclined plane. Now, if this, see, what is the net force along the inclined plane? That is mg sin theta. Net force along the inclined plane, that is mg sin theta. And what is the acceleration along the inclined plane? That is B. So mass into acceleration B. Understood? All right?
सर ए का
हाँ.
कंपोनेंट
Yes, A का component. क्योंकि इस A को you have to break this acceleration also into two parts. This angle is theta, so this will be A cos theta, and along the along the plane it is A cos theta, and along this line that is perpendicular to inclined plane, that is A sin theta. So this should be B minus A cos theta. सबको समझा? हाँ. And along the perpendicular to inclined plane, that will be C. Perpendicular to inclined plane. So along this normal. So there is a component of acceleration. It means that this acceleration is towards in this direction. So net force should also be in the same direction. So net force should be mg cos theta, mg cos theta minus n equal to mass into acceleration. Now you can see that this is fifth, this is equation, this is sixth equation. Now you can see that you have six equations, and you don't have much variable, like one variable A, one variable B, and one more like n, one more like n dash, means
So,
one
so-
normal.
So can you explain the sixth equation again?
See that when you broke this acceleration into two parts, this is A cos theta and this is A sin theta. If there is acceleration, so there should be net force. So net force should be mg cos theta minus n. Because if acceleration is in this direction, so net force also should be in the same direction.
Yes, understood.
Note it down. So you have too many equations, even like more than the number of variables. You have four variables, suppose A acceleration, B acceleration, and then one normal from here, one normal from here. So four equations, four variables. So we just need to have four equations, right? But we have six equations. Now we can very easily solve it. But doing all these things are not recommended. Now I'll tell you the shortest way. Note it down first here. Everyone noted? Okay, now see. Now I'll tell you the shortest way. See, I have to find the acceleration of block, both the blocks. Find acceleration of block A and B. See, I have to write a minimum number of equations. So you just have to assume that this is the acceleration of B with respect to wedge. See, first thing that I'll do, I'll apply the Newton's law on system. I'll make this wedge and this block as system. So if I do so, if I make this wedge and the block as system, then you can see that the normal reaction between this wedge and the block will become internal force. That will not come in picture. So one variable gone. So draw a BD on system, that is your block A plus block B. So what is the mass of the system? That is 2m, m plus m, 2m, 2m into g. Yes, there is no normal reaction between these blocks. There will be one reaction, one normal reaction from Earth to this system. Right. Now, what I'll do, this system has two acceleration. You can see acceleration A towards right. but
सर हो जाएगा.
wait. So now you can see that what I'll do, we are just apply Newton's law of motion on system in horizontal direction. Why so? Why I don't want to apply NLM on in a vertical direction? Because if I apply in a vertical direction, this M will come into picture. This M will come into picture. So I don't want to do that. Now, so we can see that there is one force N upward, other force 2mg downward. There is no force in horizontal direction. So this is 0. That is equal to mass of one object into acceleration A. If I take this side positive and this side negative, this side positive and this side negative. And B has acceleration like this, B. This is B. So it will have two components, B cos theta and B sin theta. I am not applying this concept along vertical. So I am just concerned about the horizontal component only. So this is the acceleration of wedge plus mass of block. And see, for block, there will be two acceleration, B and this is A. And this component is B cos theta. So the net acceleration should be A minus B cos theta. Understood? So for system I'm talking about. So from here you can find the relation between accelerations. But if you apply NLM in a vertical direction,
तो B का वैल्यू मिल जाएगा ना.
if you apply, I'll come to find the acceleration first. First, I'm doing like applying NLM on system. So, and if you apply, and if I apply the force in a vertical direction, so what I can see this B has two components, one along horizontal B cos theta and one along vertical, that is B sin theta. So if I apply Newton's law in vertical direction, I can see that net force is downward because acceleration is downward, B sin theta. So mass M plus M into, because this wedge cannot move down. So m into 0 plus m into b sine theta. See, this is equation number 7. This is equation number 8. We have 4 variable and we found 8 equations. So very easily we can solve. Now I'll tell you in shorter way. First you note it down.
सर 7th वाले में 0 के इक्वेट कैसे करा हमने?
क्योंकि there is no force in horizontal direction. There is on this system there will be only one normal force and one weight gravity. So there is no force along horizontal. So net force is 0. That is equal to mass
ओके सर.
m1a1 plus m2a2. Done? Noted everyone? Now I will find acceleration of both the blocks. So what I'll do, I don't want to include the normal reaction by Earth as well as normal reaction between this. So what I'll do, I'll consider the motion of this wedge or this system. See, if I don't want to consider both the normals, then we have to draw a video of this system. And we have to consider the motion along horizontal. If you consider, see, if you consider the FBD of the system, this will become internal force that will be cancelled out. And if you consider the motion of the system along horizontal, this normal will have no contribution because this normal is acting vertically upward. So this vertically upward force has no contribution in motion along horizontal. Understood? So apply Newton's law of motion on system, that is A plus B in horizontal direction. So this will be, so on this system, the force will be, net force will be 2mg and n. Acceleration is A and, okay, fine. So, okay, wait. Okay, this is the system. So there is net force along horizontal is 0 and this must be equal to m1a1 plus m2a2. So 0. m1 is what? Mass of wedge into A plus m is what? That is B is like this and A is like this. So B will have two components, this and this. This angle is theta, B cos theta and B sin theta. So net acceleration will be A minus B cos theta. So A minus B cos theta. Guys, all right now? I hope I'm clear to everyone. So M gone. So 2A is B cos theta.
So I'm slightly confused. We just derived this equation, right? Why did we do it again?
It was just like, I just showed you how to apply NLM on system. Now I'll tell you one more step. I just repeated this step.
Okay.
Now, see, we also need one more equation so that we can find A and B. Now we can see that. Now I'll consider the motion of B along inclined plane. Why? If you consider motion of B along the line perpendicular to inclined plane, you have to include normal between this. So what I'll do, see, normal is acting perpendicular to this inclined plane. And if I consider a motion of B along the inclined plane, then there is no need of including normal. See how? I'll just apply NLM on block B along inclined plane. How? See, this is mg, this is normal, and this is acceleration A, and this is acceleration B. So mg will have this component, that is mg sine theta, and because we are considering motion along inclined plane, so this force is responsible for that. So net force is downward, and what should be the okay, for this block we are considering. So what is the acceleration of this block? That is B downside, and the component of A is A cos theta. We are not concerned about the vertical component of A. So A cos theta. So net should be B minus A cos theta. B minus A cos theta. Tell me, understood or not? Now, you just have to solve these two equations. You got the answer in 2-3 steps. B minus A cos theta. Just put the value of, suppose, B or A here. So A is B by 2 cos theta into cos theta, cos square theta. So from here you can simplify this. B by 2. Or you have to find B now. Take B common. This will be 2 minus cos square theta upon 2. So B will be 2g sine theta upon 2 minus cos square theta. You put B here, you will get A. Very simple, na? In 2-3 steps, we got the answer. So you just have to identify which, where to apply NLM. So take one as system, and other you can consider along the inclined plane.
So, sir, we only need these two equations.
Sorry,
We only need these two equations.
these two equations, right?
And sir, is it something we can memorize, or will it change for each system?
No. You don't have to memorize it.
Okay.
You just have to understand the logic. Now I'll give you one question. You guys will try. And if you suppose you are asked to find the acceleration of block B with respect to ground, so you have to find net acceleration. This is with respect to which this should be the vector sum of A plus B, and you have to find the magnitude. You can easily find.
So can you repeat that?
This, see, A is the acceleration of which, and B is the acceleration of B is the acceleration of block with respect to which. So suppose you are asked to find the acceleration of block B with respect to ground. So how do you find
Right.
acceleration of block B with respect to wedge? Is acceleration of block minus acceleration of wedge. So acceleration of block, this is with respect to ground. So this is acceleration of block with respect to wedge plus acceleration of wedge. So this plus this, na? And then you have to find the magnitude of this vector. So I hope you understood the concept. You can write down NLM in any direction as per the need. Now I'll give you a question. Now you apply that. लगता है कि ज्यादा टफ हो गया, सबने अपना अपना वीडियो ऑफ कर लिया। वाह, अब ब्रो ठीक है ना, इजी था, ठीक है, एवरीवन नोटेड ना? चलो, I'll give you one question. You have to solve. This is ground, smooth. This is the wedge. Its mass is capital M. This angle is theta. One block is kept over here. Its mass is small m. Here is the pulley, same second question. And this is the row, ideal row, and it is tied to this fixed point. You have to find acceleration of both the blocks. Find acceleration of both the blocks. Just do it. Try to apply your concept. बालकों क्या हुआ आंसर आ गया आंसर लिख देता हूं मैच कर लो वेज का एक्सेलरेशन विल बी सपोज वेज का एक्सेलरेशन है जो भी है एक्सेलरेशन ऑफ वेज दैट इज mg sin theta upon m plus 2m minus ये 1 minus cos theta. Everyone got this answer? आगे तुम्हारा ब्रो
इक्वेशंस आए सॉल्व कर रहा हूँ.
करो ना.
So do we have to make an equation which includes the tension of the string?
Yes, yes, tension will definitely come.
Okay.
Okay, now let me solve. See, you can match your answer. What I'll do, I'll apply Newton's law on system m plus m along horizontal. If I consider this system and apply motion like a Newton's law in horizontal direction, then we don't have to worry about this normal that Earth will apply on this because that will apply vertically. Now, see, if you consider this whole as a system. So on this system, one normal will be acting, mass, that is, sorry, gravity, m plus m into g, and one tension will be acting. See, this tension. This tension will become internal to the system. Here tension and here tension. Both will cancel each other. So this will be outside the system. So suppose A is the acceleration of the wedge and B is the acceleration of the wedge, acceleration of the block with respect to wedge. Now, so net force on the system is T equal to mass of the acceleration, mass of the wedge into acceleration of the wedge plus mass of the block. And now this block has two acceleration, B and because of wedge as well. So this angle is theta that is given. So this will be theta. So B will have two component, B cos theta and along this B sin theta. So we are considering the motion along horizontal. So A minus B cos theta. A minus B cos theta. So we have, this is the first equation, or we can just simplify it. So T is m plus m into A minus mb cos theta. First equation. यहाँ पर किसी को कोई डाउट नहीं होना चाहिए, अगर है तो पूछो. Now, second thing would be I'll apply Newton's law of motion on this block along the inclined plane. Just remember these two things. Apply Newton's law of motion on block B along the inclined plane. Balcon, just draw the ABD of B. You can see that for B, tension is here. This tension, normal will be like this because of this inclined plane. Mg of this will be acting, right? Now, because you have to apply the Newton's law of motion along the inclined plane, so you have to break all the forces along the inclined plane. So this is already inclined to the along the inclined plane. This n is perpendicular to that, so it will not have any component along the inclined plane because this is perpendicular. Mg will have one component, Mg sin theta. Block is coming down, so Mg sin theta minus T must be equal to this is the force that we are writing on block B. So block B has two acceleration, one along the inclined plane and other with the wedge. So wedge we now we just break this acceleration into two component, A cos theta, A sin theta. So net force is downside. So net acceleration should also be downward, B minus A cos theta. Mass of this block, B minus A cos theta. This is equation number 2. Now you see how many variable you have? TAB, TAB, 3 variable. You do not have 3 equations. You need to have at least 3 equations. So for third equation, what we should do? String constraint, because one string is involved in this. One string is involved in this. So we'll use string constraint. What this string constraint says? See, suppose this segment from here to here, length is 1. From here to here, length is 2. So string constraint says that total length of the string will always be constant because string is supposed to be inextensible. So this is constant. Now we'll differentiate once. We'll get to V1 plus V2, but we are not supposed to find V1, V2. Now we are supposed to find acceleration. So we'll differentiate it twice. That is, if you differentiate it, we'll get to know acceleration of 1 plus acceleration of 2, that is 0. Now we can see that wedge is going right. So this pulley will move to right. So length of this segment, this after some time, this pulley will come over here. So this length is decreased now. So A is the rate of change, not exactly rate, but a double rate, but that is fine. Mathematics is same. So A is the rate of change of L1 is negative because L1 is decreasing. So this should be minus A, that is acceleration of the wedge, plus A2. A2, see, A2 means this, see, if this pulley goes right, this will come down. So of course, length of this string will increase. So rate of change will be positive of L2. And what is that? B only. Because B is the acceleration of the block with respect to wedge, means relative to wedge. Wedge is at rest. Now B is moving. So only B is responsible to increase the length. So A equal to B. So we have third equation over here. Now we have 3 variable, 3 equations we can easily find. How? See. One equation we have T equal to M plus M into A minus MB cos theta. First equation. Other equation we have mg sin theta minus m b minus a cos theta will be t from second equation. From here I just brought this term to left and this to right, and from here a to b. So see, t and t both are same, so these two has to be same. So m plus m into a minus a equal to b, so I'll put b equal to a here. So this will become ma cos theta equal to mg sin theta minus m. This is a minus a cos theta. So all will have a. Bring this to left. M plus m minus m cos theta plus a minus, sorry. So when this will come to left, it will become plus. So m minus m cos theta. A is out, that is mg sin theta. And this will be like m plus 2m minus 2m cos theta. And here is your answer. Mg sin theta. So from here you can find A. Tell me. Is it clear to everyone, the concept?
सर वो स्ट्रिंग कांस्टेंट वाला वो नहीं हुआ इज इक्वल्स टू बी वाला.
स्ट्रिंग कंस्टेंट क्या कहता है कि जो टोटल लेंथ होगा स्ट्रिंग का वो तो कांस्टेंट होगा ना. तो मैंने
हाँ.
मान लिया कि L1 है और ये L2 है. तो पूरा लेंथ जो होगा L1 प्लस L2 जीरो हो जाएगा, सॉरी कांस्टेंट हो जाएगा. उसको एक बार डिफरेंशिएट करोगे तो V1 प्लस V2 आएगा. अब वो मतलब देखो, जैसे मान लो कि ये L1 प्लस L2 इक्वल टू कांस्टेंट है. इसको डिफरेंशिएट करोगे DL1 बाय, ऐसा तो
हाँ
कराया
तो
हुआ
वो
नहीं
तो
कुछ.
जीरो आ जाएगा.
ये जीरो आएगा. ये क्या है? रेट ऑफ चेंज ऑफ L1, रेट ऑफ चेंज ऑफ L2. तो वेज राइट में जा रहा है, ऑफ कोर्स L1 तो घटेगा ना, तो रेट ऑफ चेंज ऑफ L1 तो जीरो नेगेटिव होगा. तो नेगेटिव किस रेट से? एक्सेलरेशन की. ये तो वेलोसिटी है, बट एक बार और डिफरेंशिएट कर देंगे तब. और बी जो है ये तुमको रिलेटिव वेलोसिटी है बी का विद रिस्पेक्ट टू वेज. तो वेज के रेस्पेक्ट में ये मूव कर रहा है. तो ये इस लेंथ को बढ़ाने का जिम्मेदारी किसका होगा? एम का.
बी एम.
तो जो L2 बढ़ेगा किस रेट से? प्लस बी रेट से. तो ए इक्वल टू बी.
अच्छा ठीक है समझ गया.
नोट कर लो पूरा अच्छे से. किसी को कोई डाउट है? टेल मी. सबने लिख लिया क्या? एवरीवन नोटेड और नॉट नोटेड येट?
हो गया सर।
सबका हो गया?
यस सर।
सर ये लास्ट लाइन 1 मिनट।
ठीक है। आई
Done,
होप
sir.
तुम, हाँ आई होप तुम लोगों को अच्छे से समझ में आया होगा कॉन्सेप्ट। लगता है एवरीवन अंडरस्टूड ना?
यस सर।
अब्रो समझ गया, अर्चित समझ गया, शाइना यू आल्सो अंडरस्टूड,
Yes, sir.
आयुषी यू आल्सो,
Yes, sir.
कदम
तो थोड़ा कंफ्यूजन है।
किधर?
तो, मतलब पूरे सम में।
तो किधर कंफ्यूजन है? पूछा क्यों नहीं, पूछते क्यों नहीं हो?
अ,
ठीक है, जो भी कंफ्यूजन हो इस क्वेश्चन में दूर करो, ट्राई करो, और वट एवर
Okay.
कंफ्यूजन यू हैव ना, जस्ट आस्क मी। दिस इज द इंक्लाइंड प्लेन, दिस इज फिक्स्ड। Suppose you have one block is like this. One block is like this. This is the block which is in contact with this plane. Hmm. There is a piston over here, piston. There is a pulley. Suppose this is connected by a string and this is connected with a fixed wall, suppose, like this. I mean, just let me draw a proper diagram. Like this. Like this. This is string. Okay. Now, mass of this block is capital M, mass of this piston is small. This angle is given theta. You have to find acceleration of blocks. This thing is, this plane, this thing is fixed. So there are two blocks, this block and this block. You have to find the acceleration of both the blocks. Just fine.
Sir, is the big block moving downwards?
Yeah, of course.
Okay. Yes, sir. Yes,
This
sir.
plane is this plane is smooth.
Okay.
If this will not move down, then friction will be as it is, na?
So, sir, we have to find the acceleration of small m and big M.
Yes.
So do we have to differentiate here also?
Because a string is involved here, na? So you have to use a string constraint as well. What do you think?
सर
We'll
हो
do.
रहा है 1 मिनट.
अच्छा हो रहा है.
Sir, can you explain it?
सर
Yes,
आंसर
I
क्या
will.
है?
तुम्हारा आंसर बोलो.
सर पहले आप बोलो.
आंसर है mg sin थीटा, मतलब लिख देता हूँ.
ठीक है सर, गलत है, बता दो.
Okay, I'll explain. See, just like suppose that if this block will not move, so in this block, this piston will move like up and down, like something like that. So see, this block will have tendency to come down, slide down, and this piston will move like this. So suppose B is the, so see, this block will slide down, this will come down, so this pulley will also come down, so this length will increase, so this has to decrease, so piston will go up with some acceleration B. And this B is acceleration of piston with respect to block, not respect to ground, right? This piston will move inside the block now. So B is the acceleration of piston with respect to block, correct? Now, just imagine system that is M plus M. This is your system. Apply Newton's law on this system along this inclined plane. Apply Newton's law along this inclined plane. This is your system. Now you can see that on this system, one mg will act downward. That is M plus M into G. Inclined plane will apply some normal force. Like here, no, here. And see, there is no normal force between this block and this and this. This will become internal force. Even this tension will become internal force. So on this system, there will be one external tension. Because this will become external, or internal. So this tension will become external. Understood? Yahan tak? Anyone has any doubt?
No, sir.
No, sir.
Okay. So now break this into component like this, theta. So this will have sine component. So this is M plus M into G sine theta. And this will be M plus M G cos theta. This system is coming down. So net force will be M plus M G sine theta minus T equal to. This is system. System has two things, this block and this block. Mass of this block, capital M, into this block is coming down. So A plus mass of this block. Now, see, this block has two things. One A because of this block, and this will have another, this B. So convert this, you have to break this into two components. One along this and along this. So this is along the inclined plane and this is perpendicular to inclined plane. You have to break this, right? Now, this angle is theta. So this angle is theta. So this angle theta, this 90 minus theta. So this angle is theta. So B will have two component, B cos theta, B sin theta along the inclined plane. We are considering the motion along the inclined plane, and every whole thing is coming down. So mass of this block along the inclined plane would be A because of this block. So A minus, and this B component is heading towards up. So A minus B sin theta. Is it clear or have any doubt?
तो ये स्टेप वापस बता सकते हो?
हाँ, एक सेकंड, एक मिनट। ये जो रोप है, ओके आई बिलीव, मैं थोड़ा डायग्राम, मैंने यहाँ गलत लिख दिया ना, डायग्राम सही है। दिस इज परपेंडिकुलर ना, इसका कंपोनेंट ही नहीं होगा। एक सेकेंड, मैं गलत बता दिया, इसीलिए कंफ्यूज हो। एक सेकेंड, दिस इज परपेंडिकुलर, सो दिस इज इंक्लाइंड प्लेन, A is along the inclined plane, and this is the B of piston, right? B of piston. But this tension, this rope is perpendicular. So this will be along the normal one. So this B will have no component along this direction. So there is no component of this. अगर ये किसी एंगल पे ऐसे होता है ना, तब होता. Rope is not like this. Rope is perpendicular. तो अभी ये ऐसा है. अभी समझा?
Yes, sir.
मतलब see, our system is capital M plus small m. उस पे FBD बनाया. Net force दिखा मुझे ये minus T equal to mass of capital M into its acceleration plus small m and into its acceleration along the inclined plane. So this piston is moving because tension is acting upward, that is perpendicular to this inclined plane. So this piston will move along the normal to this inclined plane. So this is perpendicular to this. So there is no component of B along the inclined plane. So it will have same acceleration as this block because it is moving with this block. So MA plus small m. Clear?
Yes, sir.
सबको क्लियर हुआ ये बात?
Yes, sir.
अब now apply Newton's law on piston along the line perpendicular to inclined plane. यहाँ पे क्या होगा? For this piston, see, for this piston, this is tension, and this is mg. This angle is theta. So this component is mg cos theta, this is sin theta. But we are considering the motion along the line perpendicular to inclined plane. So along this line. So this is going with b acceleration. So t minus mg cos theta equal to m into b. One minute. It will have one acceleration along this a, because this is completely perpendicular, na? So it won't have any component along this line. So m into b, that's it. ये बात समझा सबको?
Yes, sir.
Now we have three relation T A B, but we have only two equation. Now we can see that there is a string involved in this, so we can use string constraint. See, suppose this length is L1 and this segment length is L2. So L1 plus L2 is constant, just twice differentiate it. D2 L1 by dt square plus D2 L2 by dt square equal to 0. Now you can see that this block is going down. Of course, this pulley will come down, so this length will increase. So the rate of change of L1 will be positive. And who is responsible for this? This block only. So this is A. And this part, if this is increasing, so of course this piston will go up. So this part will decrease. So
So
who is
why-
responsible for that? Right?
So why is it equal to 0?
This is constant, differentiated constant.
Oh,
Differentiation of constant. And this length will decrease. And who is responsible for that? That is B. So that is minus B equal to 0. So A is B. Now you have to find A, suppose, and B. Both we can find. So here from these two equations, just add it. So this and this will be cancelled. And we'll have M plus M G sin theta minus mg cos theta equal to MA plus this MB. We have A equal to B. So we can simply say that M plus 2M into A. Put B equal to A. And then from there you can find mg sin theta minus mg cos theta plus capital MG sin theta upon m plus 2m. This is also equal to B. This is our answer. बोलो बच्चों, समझ में आया या नहीं आया?
आया सर.
Yes, sir.
मजा आ गया? Did you guys enjoy? Like, you know, how to
Yes.
apply Newton's law of motion?
Yes, sir. So can you scroll down a little bit? The last one.
Yes, madam.
No, sir, like up, scroll up.